Okay, so the issue with probability, so on the diploma, if I remember January's correct, it went puzzle questions, set theory questions, and then the permutation combination and the probability questions were kind of a little bit muddled up. And the reason why I was a little bit muddled up is because we did a permutation and combination lesson in the probability unit. So we did the perms and coms unit first, and then at the end of the probability unit, we did another perms and coms lesson. So because there's those overlapping things, you've just got to be careful when you get to that section of the test. Now, puzzles, set theory, perms and coms, and probability make up 55% of the diploma. So these four things, 4 units that we've done, so puzzles, set theory, perms and coms, probability, those 4 questions make up over half the marks of the entire exam. Okay, so you're going to feel like you're in perms and coms and probability and set theory for a really long time because it's over half the questions on the diploma. Okay, so it's not, even though it's not like algebra type math, it's very important. It's what this diploma pushes hard on. Okay. Okay, so let's start off with odds. So odds and probability are not the same thing, even though in our vernacular that we use, like when somebody says, oh, there's a 40% odds of rain tomorrow. No, there's a 40% probability of rain tomorrow. The odds of rain tomorrow are 40 to 60. They're different entirely. So when we do odds, you've got odds for and you've got odds against. They're both shown as a ratio, like this, okay? And in both cases, the numbers have to add to give the total. Okay, so in both cases, the numbers have to add to give the total. So odds for, the first number you see is the number 4. The second number you see is the number not 4, aka against. Whereas when the question says odds against, the first number you see is the number against, and the second number you see is the number 4. So on this question here, it says the odds of rain tomorrow is 3 to 1 against. So what that means is this number here is against rain. This number here is for rain. So it says the probability of rain. So the formula for probability is the number of favorable over the total number. Well, the total is adding the 3 and the 1. So which of those numbers is for rain tomorrow? Is it the 3 or the 1? The 1. So the probability of rain tomorrow is 1 out of 4. Now look at choice C. Choice C is 1 out of 3. Can you see how you might be tempted to circle C, right? Because you see a 1 and a 3 in the question. Can you see why you'd be tempted to circle A, right? Think of that as 3 over 1. What this one is probability because they got the total, but they went odds of it, probability of it not raining. They used the wrong number. So these questions are not hard. There's no mathematical calculation with them except if you count adding 2 numbers. It's reading. This is reading comprehension, unfortunately. Okay. Questions on odds. Okay. So we had 2 words in this unit. We had independent, dependent, and we had mutually exclusive, not mutually exclusive. Okay. So mutually exclusive versus non-mutually exclusive. Mutually exclusive are events with no overlap. Not mutually exclusive are events with overlap. The overlap is what we call the and, or the intersect. Okay, we learned about that in set theory. Mutually exclusive, not mutually exclusive, all of these questions contain the word or. What does or mean in math? Or means add, and means times. So for mutually exclusive, you take the probability of this one plus the probability of that one. Or means add. Not mutually exclusive, you start off the same way. You add up the two probabilities, but then you minus off the overlap. Now, that is given to you on your formula sheet. So the formula sheet says probability of A or B equals, and then there's these two formulas. But it doesn't tell you that union means or, and it doesn't tell you which one's the mutually exclusive and which one's the not mutually exclusive. Okay, so remember we talked about in this unit about how to turn your formula sheet into a cheat sheet, right? We spent a whole day looking at how to change your formula sheet to make it look proper. That's what we're talking about. Now for the independent dependent. Independent dependent, these are questions that are A and B. Okay. Independent, you're looking for the words with replacement. Dependent, you're looking for the words without replacement. Essentially, dependent, it means the first event affects the second event. It's like pulling a candy out of a jar, eating it, and then pulling another candy out of the jar. Independent would be pulling a candy out of the jar, looking at it and going, no, putting it back, pulling another candy out of the jar. That's independent. Independent questions versus dependent. And means times. So you just take your two probabilities and multiply them. Same thing here. You take your probabilities and you multiply them. But instead of writing probability of B, they write it like that. This just means that B is affected by A. That's all that means. But they just mean times. They both are just times. Okay? So, excuse me. So if we go back to the question here, a box contains 6 blue, 4 red. Fair enough. 2 balls are drawn from the box, one after the other without replacement. Okay. One after the other without replacement. So is that independent or dependent? Whoop, you didn't put the first one back. Dependent. Okay. What does complementary mean? Complementary means opposite events, right? So it'd be the first ball picking a red, the second ball picking not a red. That's complementary. Mutually exclusive talks about whether there's overlap or not. Well, I don't know if there's I don't think there's overlap here because you can't have balls are either blue or red. There's no balls that are blue and red. So these are not mutual, they are mutually exclusive, okay? But again, this question is not talking about an or question. This is an and question, right? It's just saying you're not putting those balls back, okay? So that, we spent 5 days learning that. Okay, so when you look back at it, you're like, okay, yeah, I totally get that now. Because when we went through it, it was quite painful, right? It was just keeping it all straight in your head. But this question right here, it's 1 mark, But in order to answer it correctly, you need to know everything about the unit in order to be able to answer that one question correctly. Even though there's no math, right? There's no number crunching, there's no calculator. But this one question covers like 3/4 of that entire unit. That's crazy. Okay. Okay. A card is randomly selected from a standard deck of cards. Now remember, again, they should on the diploma tell you what a standard deck of cards looks like, right? They should tell you how many black and how many red, the suits, the face cards, all that. Okay. The probability that a card is either a 6 or not a diamond. Okay. So you've got probability of 6 or the probability of not a diamond. Now, what you have to ask yourself is there any overlap? So with the or questions, you either have no overlap or you have overlap. With the and questions, I don't care if there's overlap. I'm just multiplying. So it's only with the or questions that you have to worry about overlap. So yes, there is, right? So we're going to minus that overlap. Okay. So how many 6s do you have in your deck? 4. So 4 out of 52 is the chance that it's a 6. Okay. There's 13 of each suit. So there's 13 diamonds in a deck. Okay. So that means how many are not diamonds? 39. Because I just want 52 minus 13. Now, the overlap is 6 and not a diamond. So, how many cards are 6s that are also not diamond? Because you got a 6 of diamond, a 6 of hearts, a 6 of clubs, and a 6 of spades. How many of those are a 6 and not a diamond? 3 of them. Oh, this should say minus. It's the overlap that's going to get you. Okay, that's the hard part, is remembering A, to find it, and B, how to find it. So now you just punch this in on your calculator. I think it's 40 out of 52, I think. Does that reduce down? I think it does. Just go 40 divided by 52, math 1. Pardon me? Okay, so on the diploma, they will have it in its reduced form. Okay, they won't leave it as 40 over 52. They could also make this a numeric response question and ask you for the nearest hundredth. So if you punch this into your calculator, what is the decimal to the nearest hundredth? So 40 divided by 52. 0.77. Okay, so they can make it a numeric. Now, the way numeric response gets filled in, remember there's 4 boxes. So it's 0.77. You must have the 0 in the first box. If you just go 0.77, nope. Right. So these ones start with decimals, and then it goes 0, 0, 0, 0, 1, 1, 1, 1, 2, 2, 2, 2. But I'm just saying that if you make this your numeric response answer without coloring in the 0, they will mark it wrong. You have to have the 0 colored in. So you're going to color in the 0, the point, and then the 7, 7. Okay. I think they want you, as long as you color in the dots, that's fine. I think the reason why they like you writing it in is so that if you accidentally colored in the wrong dots, they can have it to refer to. So for example, if you appeal your mark, I don't know if you know that you can appeal your mark. You can appeal your mark. It costs you, I think, $20 to do it, but then you're forced to take the appealed mark, even if it's lower. So it's a risk. But they like to have those two things there to compare them. Okay. Okay. So it says the word computer has been spelled using Scrabble tiles. 2 tiles are randomly chosen one at a time and placed in the order that they were chosen. Okay. So the assumption here is you're not putting the first tile back, right? Because you'd place a tile, place a tile. Okay. The probability that the tiles chosen are OU in that order. Okay. So you can do this as either a permutation question or as a probability question. It's up to you how you want to do it. If you want to do this as a permutation question, the reason why it's a permutation and not a combination is because the order of the letters matters, right? Order is important. So if you're going to do this as a permutation, you've got 2 blanks for the top, 2 blanks for the bottom, because you're only picking 2 tiles. How many O's are there in the word computer? How many U's are there on the word computer? So our numerator is 1 times 1. Okay. How many letters do you have to pick from? 8. So you have 8 choices for the first letter and then 7 choices for the next letter. So it's 1 out of 56. The other way you could do this is to do it this way. The probability that the first letter is O and the probability that the second letter is U. Well, you've got a 1 in 8 shot of the first letter being an 8. Sorry, the first letter being an O, and means times a 1 in 7 shot that the second letter is a U, because you haven't put the first tile back. 1 over 8 times 1 over 7 gives you the exact same answer. Okay. So nearest hundredth, what would that round to? 0.02. Now, is there a better way to do it? It's whatever way occurs to your brain. You know what's going to determine which way you do it is what came in the question before. If you just finished doing a permutations question, you're probably going to attack this as a permutations question. Okay? If you just did a probability question, then you're going to attack this probably using probability. It doesn't matter. You get the same answer regardless. Questions on that? Okay, so we did these right at the very end of the unit. I'm just going to make this not quite so small. So we talked about these tree diagrams and how they organize information. What you have to know is that, well, here, I'll explain it. So Brad is back to school shopping and buying t-shirts. The diagram below illustrates the shirts he is looking at and the associated probabilities. So the probability that he buys a North Face is 1/3. The probability that he buys a red shirt is 3/5. So then we can say that the probability that he buys a North Face shirt and it is red is 1/3 times 3/5. So that's 3 over 15. So we would go through each of our rows doing that. Okay, so this number, it would be the probability of buying a North Face and it's blue. So it would be 1/3 times 2/5. So that's 2/15. For this one, the probability that he buys a brand Buffalo and that it's red. So the probability that he buys Buffalo brand and it's also red, or in other words, a red Buffalo shirt versus a blue Buffalo shirt, okay, is going to be 2/3 times 3/4. So that is 1/2. The probability that he buys a Buffalo shirt and it also happens to be blue is 2/3 times 1/4. So that's 1/6. Now, where those numbers come from was at some point in a question, they were given. Now, this is not part of the actual solution, but I do want to remind you of something. I don't think you're going to have to create a tree diagram. I don't think so. I think you should be given a tree diagram, and then you have to go in and put the numbers in or figure it out. Remember, at each tree, so at each one, the numbers have to add to give 1. So everything, so these have to add to give 1. These have to add to give 1. Okay, so if they gave you a partial tree, so if they gave you, let's say, this one, and this one, you can fill in the others because you know that at each section of the tree that they have to add to give 1. Okay, and then to find the probabilities are all and questions. So it's north face, essentially it's red and north face. So you didn't need to do all that work to do this question. I'm just reviewing while we use the questions as our basis. Okay. So what does the question actually say? The probability 3/5 represents. So 3/5. Right. Okay, so this is north face and red. This is north face or red. This is north face given that it's red. And this is red given that it's north face. Okay, so north face and red. No, north face and red is this right here. North face and red is 3/15, not 3/5. Okay. North face or red would mean taking north face and adding it to red. Well, that's not going to be it either. So 1/3 plus 3/5, that's going to be not 3/5. Okay, it's got to be this one or this one. So that number appears second in the tree, right? You got to here, you got to 3/5 after you have already decided to buy a north face. So you've decided to buy a north face, and now you're going to make it red. So essentially what you're saying is that 3/5 represents a red shirt given that you've already decided that it's going to be north face. So it's this answer. That's the right one. It's a red shirt given that you've already decided it's north face. If it was this answer, north face given that it's red, then it would have to be red here. And then it would go north face buffalo, like that. That's how it would have to be drawn in order for the answer to be C. Okay. I didn't see any tree diagrams on the January diploma. That doesn't mean there's not going to be one for you. I just didn't see it. Okay. But I just want to take away, when you're coming up with the answers, you multiply, and each section has to add to give 1. Okay. Okay, the probability of Brad buying a non-red shirt. Okay, so which of these are non-red? Well, this one is not red, and this one is not red. So add them. Yep. So we're going to take this plus this. So 2/15 plus 1/6. So again, just use your calculator. 0.3. So near, okay, now the diploma won't do this. If it's an actual 0.3 decimal, the question will say nearest tenth. Okay. I seriously doubt they would say nearest hundredth, but whoop, if they happen to do it. So the question should say tenth. So that is how you fill it in. Remember, you always start here and work your way across. If you happen to get one where it does say hundredths, you have to fill it in like that. You have to put that 0 on the end. Now, they've stayed away from that. The mathematical reason for staying away is that does the value of 0.3 have the same value of 0.30? Well, does it represent the same number? Yes, like the same amount. So because 0.3 has the same value as 0.30, it doesn't matter that you round it differently. They have the exact same value. So if the math test is testing value, as it should be, then both answers are equivalent. So what they do on the diploma is if the answer is naturally 1 decimal, then they ask for 1 decimal. They won't ask you to put on the extra zeros. At least that's been my takeaway from the diplomas. Okay. Okay, so that was probability. So again, if you need a way more detailed view of probability, what you want to do is you want to go on to classwork, okay? You want to go down to your interview. Right here it says video reviews. You want to click on the I think I did it here. So I did perms and coms at the same time as probability. So I think I did it all in one video. So this is just a way more these videos are way more detailed with way more theory in them than what I'm doing with you right now. Okay. I'm skipping over a fair bit of stuff here. Okay, what we're doing here, that's where I'm putting these sample questions. So this was yesterday's sample questions. So that's what I'm doing with that. Okay. So just so that we're clear, if you do need extra review, that's where you want to go to that. Okay, we're going to do an absolute about face, and we're going to go to exponents and logs. So you've done 55% of the diploma. Okay, 55% of the diploma is those first 3-4 units. You're now going to move into the algebra portion of the diploma. So exponents and logs, rationals, polynomials, and sinusoidals. So the first half of the exam really has almost no algebra in it. The second half of the exam is full of it. Now, on the diploma, they like to push pretty hard the idea of context. So you might have fairly simple questions, but there will be a story that goes with it. So those stories can make the questions look rather intimidating, but they're just stories. They're just explaining what's going on. It does not change how you actually do the questions. Okay? So, half-life. So we talked about what half-life is. Half-life is how long it takes for half of an item to decay. So in other words, how long it takes to lose 50% of something. So for example, let's say we take a swab of the water fountain and find that there's 1,000 germs on it. I spray bleach. So in 15 minutes, there's only 500 germs on it. So the half-life of those germs is 15 minutes because it took 15 minutes for half of them to go away. Okay, that's what half-life is. So they give you the formula. So AT equals AO 1/2 to the T over 14.3. Again, the formulas can look terrifying, but make sure you read the stuff underneath it. So AT is the mass in grams present at time T, AO is the initial mass, or AKA start, and T is the time in days. So the way I worded it to you in class, I told you that this was the finish, this was the start, and this is how long it took to go from start to finish. That is how I worded it to you. The diploma is going to use fancier language. It doesn't matter. Now, could they give you a formula where the start is here and the finish is there? No, not in 30-2. In 30-1, they will mess with that formula and screw around with how it's written, but they will not do that to you in 30-2. So if I've called it finish, start, time, they will use fancy words, but it still means finish, start, time. So the length of time it takes for 96.2 grams of phosphorus to decay to 12.5 grams. So what is your finishing amount? Or what are you finishing with? What are you starting with? And what you're looking for is the time. That's what you're looking for. Okay, so on the diploma, if it's a multiple choice question or numeric response, you can 100% fake your way through and do it on your calculator. Okay, so let's talk about how to use your calculator, and then we're going to circle back and do it algebraically. Because on the last diploma, there was one of these that you had to solve algebraically. Okay, so if you're going to do this on your calculator, you're going to plug this into Y1, and you're going to plug this into Y2. Now, just like with polynomials and sine, you need to understand what this thing should look like before you hit graph. So y equals 12.5 is going to be a straight line through 12.5. For y2, this 96.2, this is your y-intercept. So you're going to have a y-intercept way up here at 96.2. And because it is decaying, remember we talked about decay versus growth? I know it's decay because it's half-life. So it's going to go like this. It's going to go swoop like that. Okay, so in class we talked about growth versus decay. So the reason why I know this is decay is the B numbers between 0 and 1. Remember that? 0.5. How do you know if it's growth? Just off to the side here. If it's growth, what do you guaranteed B has to be? Greater than 1. Okay, so all growth graphs look like that. Okay, decays come down. So once you know that, now all we're looking for is the intersect. But again, the calculator can only find what it can see. So you want to make sure and plug this into Y1, Y2. You want to make sure you understand what the picture should look like before you even hit graph. And then you want to muck with your window settings to make it happen. What did you get? 8 days, 26 days, 42 days, or 52 days. Now, by the way, when you see this, make X max 60, right? If you know the answers have to be between 8 and 52, make X max go to 60, and then it guarantees it will find it for you, right? Use the hints that it's giving you to help you set up these questions. So what do you get out for the intersect? 42? Yep, works for me. Okay, so you go second trace number 5, enter, enter, enter. Okay, don't go ahead to the next question. We're going to stay here. So if this is an algebra solve, so if this was a short answer question, which is how it appeared on the January exam, okay? So all of them, all algebra solves are done the exact same way. They all have the same steps. So the first thing we're going to do with every one is we're going to divide by the 96.2. Or in other words, whatever number is here, that's the first thing you do, is you divide by that number. So on both sides, I'm going to divide by 96.2. And then that goes away. Now, don't worry about how messy this thing looks. Just leave it alone. Okay, don't worry about it. Just leave it be. So the second thing you're now going to do, and this is the algebra piece, we're going to convert to a logarithm. Okay. So when you convert to a log, there are three things. There is the base, there is the exponent, and there is the value. Okay? So when you look at your equation here, 12.5 over 96.2 equals 1/2 to the t over 14.3. Which one of those is the base? Which one has the exponent attached to it? Right? So the base is 1/2. Right? The base is at the bottom of the exponent. Okay. What is the exponent? So the exponent is the t over 14.3, which leaves the value as this. Okay. To plug this in on your calculator, you're going to use your MAM key. Math, alpha, math. Remember that? So math, alpha, math. And you're going to get out a number. Now, I'm trying to get t by itself. Right now, t is being divided by 14.3. So how do I move that over? Times. So my final answer will be whatever this number is times 14.3. And if we did the graphing one right, should get out 42. Okay. Okay. So again, on this question, if it's multiple choice, honestly, if it's multiple choice, just do a Y1, Y2. But make sure that you understand what the picture should look like because the calculator can only find what it can see, right? But if this is a long answer question, so if this exact question appears in the written response, this is the algebra process. The algebra process is the same for everything. So the first thing you do is divide by that first number. The second thing you do is convert it to a log. And that's it. It's the same two steps every single time. Okay? Okay, so log laws. So on your formula sheet is all of the log laws. Okay? So you don't have to have them memorized. You just have to know how to use them. So the first thing that you have to do when you're using log laws is you have to use the power rule. So I'm going to do each of these in a different color so you can see what order I'm doing them in. So the first thing that you have to do is you have to take any number in front and kick it back to the power position. So any number in front, kick it back. Now, if there is a subtract, you leave the subtract alone and you just kick back the 5. So now what you have is log 8 squared plus log 4 cubed minus log 2 to the 5th. Okay, so that's step 1. So step 1 is always use the power rule. Now, just as a side note, when there's no base given on a log, what's the assumed value? What's the assumed base every time? 10. Not 1, not 0, 10. So you don't have to write it in. If it's a number other than 10, then you have to write it in. But if it's 10, you get to leave it off. Now, for the second thing, it's going to be using this or this. So when you bring it together, as a single log, the first term always goes in the numerator. Anything that has a plus in front of it will go in the numerator. Anything with a minus in front of it will go in the denominator. And you multiply everything that you have. Sorry, I was supposed to do a different color. Sorry about that. So, log base 10. So this is the first thing that I have, is 8 squared. So the first thing that you have goes in the numerator. That's what I mean by that. Okay. If there is a plus sign in front, if there's a plus sign in front, it goes into the numerator. So you're going to write 4 cubed, and you're going to multiply. That's what that means. Yep. Okay. If there is a minus in front, then that goes into the denominator. Okay. Not negative 2 to the fifth, just the 2 to the fifth. The minus is what's controlling the position. Now, if we had another term that was minus, so if we had another minus log base 10 of, then that would also go in the denominator and we would multiply those together. That's what this means. This means times. No, it's a times. Okay, so which one does this match to? Well, it matches that one. Okay, so it matches that one bang on, right? The 3 equivalent expressions. Okay, if we look at this step right here, that is this one. That one's when they just use the power rule. So that's another equivalent expression. So when they just used the power rule, we got this. When I did the power rule and what I called the product rule and the quotient rule, I got this. Now, if you punch this into your calculator, okay, just that. So 8 squared times 4 cubed divided by 2 to the fifth. So 8 squared times 4 cubed divided by 2 to the fifth. I get out 128. Okay? So just punching it in exactly as I see it. So I get out log base 10 of 128. Now it just so happens that 128 is the exact same as 2 to the power of 7. So this is the other one that is true. So which 3 expressions? Numbers 1, 3, and 4. So numerical response. Remember, you start here. Now, because it says in any order, the answers could be 1, 3, 4, 1, 4, 3, 3, 1, 4, 3, 4, 1, 4, 1, 3, 4, 3, 1. Any of those will give you out a right answer. So when it says put them in any order, it's entirely up to you which one you want to do. Okay. So again, log laws. It's a guaranteed probably 2 questions on the diploma will be log laws. Guaranteed. I'll come back to the slides so you guys can fill it in. Okay. Okay, so here's another log laws. Okay. So first thing we have to do is we're going to use the power rule. So we've got to take this 3 and shimmy it back. Take this 3, shimmy it back. Remember, don't hit the subtract. Just take the 3. So we've got log base 10 of a cubed minus log base 10 of b cubed. Now the second thing is you've got to decide where to put your stuff. So the first one always goes in the top. there's a plus in front of it, it goes in the numerator. If there's a minus in front of it, it goes in the denominator. So we're going to have log base 10. So a cubed is first, so it goes in the top. We have a minus in front. So does the b cubed go in the top or in the bottom? Bottom, because it's got a minus in front. So that, okay, so now, so it doesn't match. So what often happens is they're going to, so there's nothing wrong with that answer, by the way. That answer, if this was a short answer question and you did that, you get 100%. But as a multiple choice question, we have to keep going. So usually what happens now as a third step is we're going to use exponent laws to simplify. So what we would do with this. So when you've got powers touching, so for example, if you have 3 squared all to the 5th, what do you do with the 2 and the 5? What do you do when powers touch? Multiply. So you end up with 3 to the power of 10, right? So what we can do with this is because both of these are the same number, what we can do is we can take that power out and write it up here. Because if we were to go in reverse, you would do a to the power of 3, b to the power of 3. And then now we're right back to here where we started. Now this one matches that. So after you've done your log laws, so after you've done steps 1 and 2, if it doesn't match, keep going with exponent laws until you find a match. Okay, so like I said, I'll come back to these 2 slides so you guys can fill it all in a little bit better. Whoops. Okay, graphing. It's probably a guarantee that you're going to get one graphing question. So you don't have to have the following thing memorized, but it does help in terms of cutting down how much guessing and checking you have to do. So this is called the exponential function. Y equals a times b to the x. If b is a number bigger than 1, this is referred to as growth, and the graphs have that as the a value, and they go swoop up to the right. If b is between 0 and 1, it's called decay, same a value, but the graph goes down. That's exponential growth and exponential decay. For logs, what it looks like is this. Y equals a times log base b of x. If b is bigger than 1, it's called log growth. And it looks like this. And if b is between 0 and 1, it's called decay, same as the other one. But it looks like that. Now, this, 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 is called an asymptote. So, do you need to have that memorized? No, but it helps. It helps cut down a lot of the guessing checking that you have to do. So you can see here that this thing's got 4 graphs. If you notice that B, so how am I going to do this? It's got 4 colors. So C is this one. C is exponential growth. Okay. Asymptote, yeah. B is exponential decay. A is log growth. And finally, D is log decay. So if you had to do a guess, the question says the graph that best represents A log BX. Which graph should not even be in contention? What colors? If you're looking for a log graph, which two should not even be in contention? Yellow and green. So yellow is C, green is B. These are exponential graphs. Okay? So if you knew that, you could at least get down to a 50-50 guess. Okay? So how do you then figure out the rest? Well, this B is between 0 and 1. This means decay. And decay is that one. So which one is the purple one? The purple is graph D. Now, let's talk about cheating. Okay. What does this mean? A greater than 0. What type of number does A have to be? A greater than 0 means A is positive. So, give me an example of a positive number. Thank you. Okay. This means that B is between 0 and 1. Give me a number that's between 0 and 1. Half. Okay. You have a graphing calculator. Let's use it. Okay, so we're going to go 6. Now, math alpha math. So log base a half of x. So it doesn't matter if Reese picks 10, Kaylee picks 6, Josh picks 2, Abby picks 7. It doesn't matter as long as it's a positive number. You could pick 349 for all I care. For B, you could pick 1/2, 1/3, 3/4, 7/8, 9/16. I don't care as long as it's a number between 0 and 1. Could you also do a decimal like 0.2, 0.7, 0.4? Yes. Let's see what she looks like. Okay, so it's kind of got that. You can kind of see it's like going like this, and then it's kind of got a little slopey thing happening there. Either way, that should be enough information for you to match it. Woo! To graph D. So even if you don't know the 4 pictures, you have a graphing calculator in front of you. Don't forget to have that. The key to the graphing calculator is you have to know what that means. If you don't know what that means, you're going to punch the wrong thing in on your calculator. Okay, and then you're going to get a wrong match. Okay, I think we got 2 more. Nope, last one. Okay, so the 2010 earthquake in Haiti. So this is another problem-solving one. And they love to pick on at earthquakes. The 2010 earthquake in Haiti measured 7.0 on the Richter scale. In 2004, an earthquake off Indonesia measured 9.1 on the same scale causing a tsunami. In order to compare the relative intensities of these 2 earthquakes, the following formula may be used, where M and N are the Richter scale values of each earthquake. Okay? compared to the earthquake in Haiti, the earthquake off Indonesia to the nearest whole number was blank times stronger. Okay, so do you understand that Indonesia is going to be stronger than Haiti? Because Indonesia has a higher number than Haiti. So in order to get out a number, okay, think about it like this. Is 2 divided by 4 the same as 4 divided by 2? No. 2 divided by 4 will give you a small decimal, whereas 4 divided by 2 will give you a large integer. So we want to make sure that when we plug this in here, we do the larger one on top and the lesser one on the bottom, because we want to end up with a number that is stronger, right? We want to end up with a big integer. So you just punch into your calculator. So just go 10 to the 9.1 divided by 10 to the power of 7. And you get out how many times stronger? To the nearest whole number, 126 times stronger. Now notice if you had accidentally put that in upside down, if you went 10 to the power of 7 divided by 10 to the power of 9.1, you get out 0.00794. So to say it's 0.008 times stronger, that does not make sense, right? So if you plug it in upside down, you know you've done something wrong. Again, is that hard? No, it's drag and drop of numbers. The reason why this isn't exponents and logs is because those are exponents. That's the only reason why this concept is in here. Okay, the only thing I haven't covered with you is regression. So if you're asked to do an exponential regression, okay, the points that you get will either look like that or like that. Like they'll either swoop up or swoop down. The EXP reg key is letter M0. And the equation that you're going to get is that. So it's list 1, list 2. Make sure your stat plot is turned on, right? Window settings, all that. If it asks you for a log regression, then the points will look like that or like that. And you pick letter 9. Letter 9, it says LN reg. Like that. So read the question carefully as to whether or not the question says exponential regression or logarithmic regression. So do you remember in polynomials? In polynomials, it would sometimes just say a polynomial regression, and you had to decide if it was linear, quadratic, or cubic. They won't do that with this. They will tell you if it's exponential regression or log regression. You just got to make sure that you pick the right choice. So pick either 0 for EXP reg or 9 for ln reg. Okay. And remember ln, you've probably forgotten because we literally spent no time on it. Ln is the exact same thing as saying log base e of x. And e is this number, 2.71. Okay. Okay,